Hey fellas, so today I'm going to tell you a very short and sweet little proof of Cauchy mean value theorem. But the only thing is that it's a wrong proof. So you have to see this proof and you have to tell me what is the flaw in this proof. Okay, so I'll be waiting for your answers in the comment section. So yeah, let us start the proof. So what does Cauchy mean value theorem says? It says that if you have two functions, f and g are the two functions, and they are nice functions, as in what they satisfies that they are continuous on closed interval ab, differentiable on open interval ab, and the derivative of g is non-zero for all interior points of the interval ab. Then there exists a point such that the nice thing holds. And what is that nice thing? F dash of c upon g dash of c is equal to f of b minus f of a upon g of b minus g of a. Okay, cool. So let's start with the proof. So what is given to me? It is given to me that our function f is from close AB to R such that your f is continuous on closed interval AB and your f is differentiable on open interval AB. Good, but whenever we have such a function satisfying these two conditions, you can always recall your mean value theorem. That is the Lagrange mean value theorem. So what does Lagrange mean value theorem says? If you have a function that is continuous and differentiable on closed and open interval AB respectively, then there exists a point such that this thing holds. So if I apply mean value theorem to my function f, then what do I get? I get that there exists a point C belongs to open interval AB such that my f dash of C is equal to f of B minus f of A upon B minus A. Cool. So let me call this as equation 1. Now what is given to me? It is also given to us that our function g satisfies these two conditions. That means what? Your g is a function from close AB to R such that your g is continuous on close AB and differentiable on open AB. So again, if I apply the mean value theorem to my function g, then what will I get? I will get that there exists a point C belongs to open interval AB such that your g dash of C is equal to g of B minus g of A upon B minus A. And let me call this as my equation number 2. Now what you do, you divide 1 upon 2. If I do 1 divided by 2, what do I get? I get f dash of C upon g dash of C is equal to this ratio, this divided by this. And when you do this division, what will happen? Your b minus a and b minus a will get cancelled. What you are left with? Ultimately, what you will get is you will get f dash of c upon g dash of c is equal to f of b minus f of a upon g of b minus g of a. So this is a sweet little proof that you apply mean value theorem, Lagrange mean value theorem to the function f and to the function g, and you simply divide these two things, you get the answer. But as I said at the start that there is some flaw in this proof. So yeah, now it's your job to tell me what is the flaw. So yeah, thank you.